Okay, so today we are wrapping up our experiment that you all conducted yesterday, where you kept the voltage of a battery as a constant. So you all were using a 9-volt battery the whole time, and then you varied the resistance in a light bulb and measured the current as you changed that resistance. And so the independent variable in our experiment was the resistance, and the dependent variable, what you were seeing was affected by that resistance, was our current. And I'm only shorthanding those to RES and CUR here because I'm running out of room over there. But as I label my axes, and remember that we always, in experimental design, when we present our data, we would put our independent variable on the x-axis and our dependent variable on the y-axis. I would probably write out this entire resistance and current, and then remember your units. So remember, and if you need to look back at your work for Monday, remember what unit current is measured in, as well as the unit that resistance is usually measured in as well, but you would want to include those as labels on your graph. Other important notes, you all, I'm asking you to create dots for your data or mark your data points on here. We're not making bar graphs with anything we're doing today. And I'm just placing those randomly right now. And I'm going to ask you to connect your data points by lines. I do not expect this data to be strictly linear, but to show some kind of trend, I'll ask you to connect each data point to the next one, to the increasing whatever your independent variable is for our increasing resistances. Now, the last thing that I ask you to do today is looking at the trend that you see. So the trend that I'm seeing here is, okay, it looks like my current, which is my dependent variable, goes down as resistance goes up, but then current starts to go up. So my trend doesn't really make a whole lot of sense, but my goal for what that last question is would be somehow to explain what I'm seeing here, what the trend that this data is showing based on what I know about resistance and what I know about current. So if you feel unsure or if you might have forgotten from our Monday work what each of those two words mean, maybe take a look back at that Monday video just to get a quick review of what those two words are, what resistance and current are for our electrical circuits. But that's the goal of that last question. There isn't necessarily one right answer, but you want to show that you understand what these two words mean, what resistance and current mean in the context of electrical circuits, and connect that to what you were seeing in this experiment or this quick investigation that you all were running over the past couple days.